Alright. Oh, wow, those levels are off. One sec. I'm peaking like hell. Let's just dip that down. Okay. Hello, everyone. Let's get my actual monitor going. How are you all? Oh my god, so many messages already. Okay, I'm gonna answer this one first because it's really quick. How do I simulcast? There is a extension called Multiple Output made by Sorayuki. That's free and open source. It's for OBS, and you can basically stream locally to 2 targets. Just like how you normally stream to 1 target, but you can do it twice. It takes double the bandwidth because you're going to 2 services, but it's free, and you know, the other ones that like you send a stream to a website and then it spreads it out cost money. And I didn't want to spend money, and I have Ethernet, so I just simulcast locally. Hi everyone, hi Jordal, hi Archie, hi Zith, hi the world's longest username, hi Colton, hi Jasper, hi Base2 Oblivion. Okay, there's already a lot of messages. Okay, so oh, thank you for the sub, Zith. Hey Prop Fox, how you doing? Okay, Jordal says, will I finally get to know what threading is? Hopefully, I can explain what threading is in this live stream. Basically, the idea of multi-threading is that instead of having a single linear flow of code that is being executed on like one core of your CPU from top to bottom, you can have multiple independent cores that are working on their own things simultaneously and occasionally connect together to share information. And the reason that lots of programs don't do it is because it's really, really annoying. Because the whole thing about like having multiple threads being independent means that it's really hard to share information in a way that's consistent and doesn't cause race conditions, which is where information is trying to be modified or read in 2 places at once and then get some like non-determinate ordering, or deadlocks, where you try to organize when things are reading stuff, but then they both ask to read something at the same time and are blocked by each other and kill everything. That's true, yeah, you can also have multiple threads in the same core. I guess when I say thread, I kind of mix my terminology between hardware and software threads. Any given CPU is going to have a certain number of cores, which will each support a certain number of hardware threads, and then the OS lets you spawn pretty much as many software threads as you want and tries to allocate them to the hardware threads. So concurrency in concept, not always in practice. If you're on a single core machine, it'll still let you, well, single core, single thread machine, it'll still let you create as many software threads as you want, but it won't actually be doing anything simultaneously. But it's still a good practice to try and allocate more or less as many threads as the hardware allows for, because you're going to get maximum theoretical concurrency with that. Through OBS, free is good, thanks. Yeah, glad I can help. I was trying to use Restreamer at first when I started to simulcast, and it puts a giant little badge in the bottom right of your screen, and you have to spend $16 a month to get rid of it, and I was like, surely I can do better than that, right? Yeah, multi-threading is super complex. I'm not particularly good at it yet. I'm kind of messing around. You're gonna see some cursed code this stream when I go over how I did some multi-threaded mesh uploading stuff. Just know that it is temporary, and I recognize it's awful. That's all I ask. PropFox says Mutex locks my beloved. I've been getting really into non-locking concurrency, like through message passing. I think that's really cool, but also it very much limits the model of things you can do. But like also most of my knowledge in this is kind of just me learning stuff as I go and probably not having the best techniques to work with any of the data that I'm using yet. But yeah, okay, let's start with a little demonstration. I'm gonna explain the problem for why I did multi-threaded mesh rendering, and then I'm gonna show you the implementation. So first, let me quickly stash my changes. And then let me touch the CMake list file to force it to reglob my stuff, because CMake is dumb and old. And now when I run Zephyr, we should be on a version that does not use multi-threaded mesh uploading. Okay, are you using multi-producer single consumer? I'm actually currently using multi-producer multi-consumer queues, because there's like a really popular, really fast library for C++ that does it. It's, let me see, where is it? It's somewhere in here. It's probably in thread executor, or wait, task executor. No. Concurrent queue. It's called concurrent queue, and it's by Cameron 314. But I did write my own multi-reader and multi-writer queues before that, and then I found there was some weird seg faults that were happening, and I didn't really want to debug them, so I ended up just swapping over to the library version, and frankly, the performance it's going to get is probably better than anything I could do myself. Yeah, so here is, let me actually restart the game so that things are a bit more obvious. So, right now, I have this task executor, which if I open the world file, it dynamically allocates threads to tasks, and each task has like a spec. So this is the spec for the map gen tasks, and this is the spec for the mesh generator tasks, which is a lot longer. And so for example, the map gen task, its processor, which runs on its own thread, creates a result type that contains the result of generating the map around a position. So this whole function block here will run in a different thread than the main thread. And then my post processor here operates on the data in the main thread after it's done, and that is passed back to the main thread using a queue, basically. So whatever this thing returns will get sent back to the main thread and then run through this at the end. And at this point, this post processor for the map gen stuff just tells the engine to mesh all of the chunks that it just generated. And then mesh chunk basically just does a little bit of work and then enqueues a mesh task into the executor, which means that this task will be run. Preprocessor just collects all the data and sends it to the thread. Then processor runs on the thread and actually meshes the region. And then in this older version, the post processor takes back all the mesh data and then uploads it to the GPU on the main thread. That's what this add mesh call does. It does a bunch of funky stuff with like buffered meshes, but the point is that the mesh data is generated on a different thread, and then it's sent to the main thread and then put on the GPU on the main thread. And the reason I was doing it like that is basically just residual nonsense from OpenGL, because OpenGL really does not like doing multi-threaded mesh uploads. So the system was always just get the data that I need to mesh, put it on another thread, mesh it over there, send back the geometry, and then upload it on the main thread. But I did some profiling yesterday, or maybe 2 days ago, I don't remember, and that's what this line down here, the average mesh upload time is, and I realized that we're wasting a shit ton of time. Like, you can see it's 0.3 milliseconds to mesh a single chunk, or to upload a single chunk. This is after it's meshed, this is just putting it on the GPU, and that happens on the main thread, and even that initial region there is 3,000 chunks. Like, 2805 chunks times 0.33 of a millisecond, divided by 1,000 for seconds, that's almost a second of wasted time on the main thread, which, if we put that into frames, multiply it by 60, that's 55 frames that are, like, extra in just, like, generating this terrain. And so obviously I wanted to take advantage of the fact that Vulkan can upload meshes on a different thread, but I wasn't entirely sure how to do it, so I went over to the graphics programming Discord, and I was like, help, guys, how do I upload on multiple threads? And the people there are incredibly nice, and they basically told me I needed to create another queue. I'll actually give some code examples here. Let me swap over to the latest version now. If we go over to the renderer, and I go to queue, so basically oh, hold on, there's new comments. Just started learning Vulkan, it's such a process, any advice? My biggest advice would be join the graphics programming Discord. And then also, check out VK Guide, vkguide.dev. It's an absolutely excellent resource. It's where I basically learn stuff in addition to pestering people in that Discord a lot. But no, the graphics programming Discord is excellent. Is there a reason you always use the same world in your presentations? No, there is the ability to have a random seed. I just don't actually know where that is. It's been a long time since I've edited the seed. I think actually if I go to the dimension file, no, not that one, dimension.ts, can I do a seed offset in here? No. You can specify the seed somewhere, but I don't really remember where it is, and having the same seed every time is convenient for just like testing features over time. And so I just continue to use the same one. If you look at older videos or stuff on like Tumblr or whatever, I do swap worlds occasionally. But it's just nice for consistency because I don't have a good system for spawning you on like solid ground yet. So depending on what the seed is, I could spawn very far underground or very far above the ground. And it's nicer to be able to always have the same world so I know what's going on. Colton says, would you mind explaining the gist of non-locking message-based thread handling thingy? Okay, so am I making a game engine? Yes. Okay, so the basic thing about message-based thread handling is there are two ways to do multi-threading. So you need to control access to your data in some way that doesn't allow multiple threads to access the same data at the same time, or at least doesn't allow them to mutate data at the same time as another thread is reading it. Because if one thread's modifying something as another thread's reading it, you can get really bad corrupted results. And so the two main ways of doing that are either using a mutex, which stands for mutual exclusion, and I do that in the mesh uploader, so I'll show an example there. This is going to go away soon though, to be clear, because I think mutexes are generally a worse way to do this. But if I look at the mesh uploader, you can see at the beginning of this block I say chunk mesh buffers lock.lockWrite, and this returns a lock. And the way that this actually works is as soon as I call this function, it freezes this entire thread until nothing else is using this lock, and then claims the lock afterwards. And then for this entire span, until I unlock it here, nothing else can use that lock and will hang until basically all of this is done. And then when I unlock it, it releases it again. And then basically you can actually access the data on different threads. And that's what mutual exclusion does. It's pretty much the simplest way to do multi-threading, because it's just, I'm going to say this thread's going to use stuff and nothing else can touch it while it's using it. And then after it's done, this thread can use stuff and it's going to stop anyone from using it elsewhere. Oh, thank you for the subscription, Archie. Oh shit, 3-month streak. Okay. Why is it so hard to add a new card to Google Play? Oh well, wish you the best of luck with Zephyr. Thank you. Yeah, Google Pay is a little bit goofy. For some reason, my Google Wallet recently keeps asking me when I try to make payments with my phone if I want to pay it using Google Wallet or Google Wallet with the same icon, and I just have to tap one of them, and it's really annoying. I don't have 2 copies of the app installed, it's just being stupid. Yeah, but so that's mutual exclusion, and message passing is a bit different. So there's kind of models that you can make where you can create a queue that can be inserted to and read from without doing any locking. Basically, if you just say that the only operations are being able to read from the start and append at the end, you can kind of store the last safe read position and the last written position, and you can add things in a way that doesn't mess with any previous data and read things in a way that doesn't mess with the data that hasn't been written yet, which allows you to send information from one thread to another without having any locking. The trade-off is that once data goes from one thread to another, you can't safely access it on the initial thread. And any data that you want to transfer needs to be transferable, which means it can't depend on anything that is being used in a different thread. Otherwise, you're kind of defeating the purpose of transferring it. But that works really well with like the task executor, because it basically just takes in a big queue. This code is really hard to read, but if I go to enqueue here, it basically takes in a big like task and then queues it into a multi-threaded queue. And then on the task threads, they read from there, do whatever they want to do, and then shove it back in the other queue. And then that goes back to the main thread. So it works really well if you want to dispatch work to a different thread without causing any like delays on the main thread. But it doesn't work great if you're trying to explicitly synchronize stuff. It only really works if you don't care exactly when things happen. You just want to know that they will happen at some point. Oh shit, I'm seeing a bunch of hydrates already. Okay, there's 2 here. I'm doing 2 hydrates. 1. 2. Also posture check. Thank you. I'm kind of slouching. I did your hydrate. That was one of the 2. Don't try and sneak in another one. I know how you are. Okay, let me quickly see. Okay, Radio Dwarf says hello, hello. Jordal says you'll check out something. I don't remember at this point. It might have been the Q thing. Okay, let's see. Would you mind explaining the gist of non-locking oh wait, I already did that. Okay, making a game engine, yeah, caught up with that. Oh yeah, you can calculate a height map using bitmasks. The problem with that for my engine, I'm assuming you're talking about spawning, is that you can generate the world using 3D noise and the world height is infinite, so I can't necessarily ensure that there is a top point of the world at any point. I need to do some fancy heuristics to try and figure out what is likely the surface or something, and I haven't really decided how I'm going to do that yet. Would a custom renderer with rasterized quads for a voxel game be a good idea? It really depends on what you want to do. Like, for example, my engine here, oh, this might not... Hold on, I think I fucked this up. I need to stop this. Then I need to touch the file. Now I can build. My engine uses a lot of non-cubic geometry, like with low poly planes and stuff, which would be messy to do with ray tracing. But if you want to do just an engine or an environment that only supports true voxels, as in single-colored cubic things, and you want to have a lot of them, then ray tracing is probably your best bet. It really depends. Like, it depends on the art style that you want to do, because ray tracing is super efficient if you have a card that can support it, but also constrains your design a lot. But then, like, rasterization also constrains your design in a different direction, right? So it's kind of it's a give and take. If you have a set world height, yeah, I don't have a set world height, I'm sorry. Question, is there anything like Rust's move semantic in C++, or do you need to uphold moving stuff through the channel on your own? There is a unique pointer type. There's a unique pointer type which you have to move. It doesn't have copy semantics. So in C++, a structure, if you try to like assign it by value, will implicitly try to copy unless you tell it to move. And those are two different kind of specialized constructors, and you can delete those constructors on types if you want to. So you can say this one isn't allowed to move, or this one isn't allowed to copy. But there's still a bunch of funky stuff you can use to break that rule, and types usually don't enforce it by default. It's kind of a mess. Rust is a lot more robust with that sort of thing. I think you're rad and good. The subjects go way over my head, but I want to show support regardless. Have a good stream. Thank you! Thank you. I really appreciate that. Why is it copy by default feels so stupid? Because C++ is a bit of a mess. I don't know, it's just the way it is. I'm sorry to have to tell you, but yeah, no, C++ is bad. Okay, yeah, but multi-threaded mesh uploads. Let's quickly talk about this. So I know I got super sidetracked, but the basis was that in the old version, meshes would get generated on their, chunks would generate on their own threads. Then it would dispatch requests to mesh all of the terrain on the on a different thread. Then you'd get back all of the mesh data and upload it on the main thread, which took about a second for just the spawn area of just raw computing time, which is awful. In this version, the mesh task still collects data on the main thread. This is something I want to look into seeing if I can reduce in cost. But then, it doesn't have a post-processor anymore. It doesn't do anything on the main thread after the processor. And what happens on the processor is it generates the mesh, and then it enqueues it into the mesh uploader. And this is a new object. If I go over to the enqueue method, the mesh uploader exists once in the game, and the enqueue function adds it to upload jobs, which is another one of those fancy queues. If I go over to the header, upload jobs is one of those concurrent queues. So it doesn't matter how many threads call enqueue at once, it'll always synchronize properly. And then, so once it's enqueued, this mesh uploader has its own thread function, which basically just waits for a buffer, a command buffer, sorry, to be available, pushes the mesh into that buffer, and then dispatches the buffer to the GPU to upload the mesh. That was a lot of terminology soup, so I'm gonna talk about what a buffer is and what, like, threading in Vulkan even entails. Let me just quickly read the messages. Copy by default is good. I assume you're saying it's good as opposed to copy by, like... I assume you're saying it's good as opposed to pass by reference, where like all objects are pointers, and I completely agree with that. But I feel like we should be passing by value and also have move semantics by default, unless you explicitly request a clone or a copy. Like, I think that's how Rust works, and I think that's good. Like, I don't want to support, like, pass by reference by default, because that's bad. But, like, yeah. Is there a specific reason that you don't have an exact world height? Basically because this is meant to be a general engine that can support anything. And I know, like, even for the game that I want to make in this engine, I'm wanting to have a world that's, like, a couple thousand blocks tall. And at that point, it's kind of a struggle to do anything meaningful, or like, to have any meaningful optimizations with a fixed world height at that scale. And so I may as well just do cubic chunks and infinite world height. Also, hi, Toffee. Okay, is there any... Oh, wait. Are all objects or pointers? That sounds hellish. Not in C++. You can do that, and that's certainly how I started, because my first experience with programming was in Java, where all non-primitive objects were pointers, and I was just like, yeah, the new keywords, that's good, I should use that for everything. Terrible idea. But, yeah, in languages like JavaScript, any object type is effectively a pointer, and every pass-by is a pass-by reference. It's kind of gross. Okay, so let's quickly go over how Vulkan's multi-threaded mesh uploading works, because that's something that you can't do. Wait, hold on. I do just think the rule of everything's a copy unless explicitly marked as ref is pretty simple to use rather than C# where structs are passed by val, classes by ref, etc. But move semantics by default is good, but that's still a mental stack. So I agree with you that it should not be passed by ref by default ever. References should be explicit, and copy should be explicit, and move should be the default and enforced by the compiler, similar to Rust. Like, if you pass an object without it being a reference, it should assume that it's a move and prevent you from using it after that, unless you clone it, like, explicitly. I don't want my memory being duplicated without me being aware of it, like, very clearly in my code. Like, it should always be using the cheapest option by default. Hey there, Laughlins Art, how you doing? Pirate Raid, woo! That's how it is in C# as well, references / primitive types. Yeah, oh god. I hate that so many languages started doing that. But yeah, so in OpenGL, you could not multi-thread mesh uploads at all. In fact, all commands to the GPU had to be in one main thread. And there were some very specific ways that you could get around that, but they were super janky, and I never tried to learn them because I knew that they were going to be really dumb. In Vulkan, though, instead of writing commands directly to the GPU at all times, you write commands to buffers and then submit them to queues. And any given queue can only be written to in one thread at a time, and any given buffer can also be only written to in one thread at a time. But multiple multiple queues can run independently of each other simultaneously across multiple threads. So in this create command buffers function that I have, I create these two command buffers, which both run on the main thread. They're basically just like the regular buffers and queues. And then I also create this command pool and queue, which is for the mesh uploader specifically. It creates one transfer pool, which is a pool of command buffers, and then it creates, I think, 5 buffers? Yeah, num transfer buffers is 5. It creates 5 buffers, which are only meant to be used in the mesh uploader. And then, so the mesh uploader, when it's doing stuff, basically just has to grab one of the queues, and then use it, and then mark it as still being used. So, like, if I go over to the mesh uploader, in the thread function, I find the first free buffer by basically just going through my my buffer states and looking for one that's idle. And then I create my like all of my mesh commands, and then I submit it using that buffer, and then I tell that buffer that it's busy until the sync point gets hit. I know that's like a very rough overview. It's not super clear, I guess, but basically, there's like 5 buffers, and I cycle through them on the mesh uploader, because after you submit one, you have to wait till it's done to use it again. And then I basically just use the sync point on the GPU to track when one buffer is done, and then mark it as usable again. Doing very well. How's the Voxel development coming along? Are we multi-threading? Is this an underwater basket weaving class? Not yet. Maybe one day. No, but the multi-threading's going very well. Let's see. Hey there, Gabe. Jordal says, I think I'm starting to get it in a basic level. Okay. Yeah, if you have any more questions, let me know, because it's hard for me to know how detailed to get into this stuff, like if I don't know what questions I'm trying to answer. But yeah, the gist of it is that big performance improvements are made, because all that time, that 1 second of mesh upload time that was on the main thread is now on its own thread, completely independent of rendering. So I used to get these very visible stutters when meshes were being uploaded because it would halt the main thread and it was hard to like actually maintain a consistent frame rate while that was happening. But now I don't get those at all. Like if I just like wander through here, you can see the task status on the right. Blue means that it's generating chunks and red means it's meshing chunks, but it basically runs consistently the whole time, which is really good. Efficiency TM, yeah. Oh yeah, let is just defined to be auto, and CNS is defined to be const auto. I know that's kind of sinful, but it's the way I write code. Yes, we do have actual world gen now. I completely forgot to mention that. So the whole point of multi-threading the mesh uploads is now I can have infinite terrain. It doesn't garbage collect any of the old terrain yet. That's a whole other can of worms, because now all of the meshes are being uploaded on that uploader thread. I also need to synchronize deletions on that thread as well, and I haven't decided to do that yet. I mean, to be fair, I literally just finished this multi-threading implementation like 10 minutes before the stream, so it's not exactly been that much time. But yes, there's actual world gen now. I can just fly in one direction until my GPU starts freaking out because I'm using like 1,000,000 gigabytes of memory. Let's see. Yeah, I'm using 4 gigabytes of VRAM right now. Woo. Distant blocks aren't just facades, let's go! Yeah, well, that's actually mainly just because I haven't yet done the tiered mesh uploading, or the tiered mesh gen yet. That's actually probably the next job for me, is setting up an octree so that meshes in the distance will still be low resolution, and then as you approach them, they'll get higher. Because, like, people that have showed up for previous streams would know that when I would fly far away from the world origin, it would end up having like a lot of weird artifacting, like this artifacting here, where you can't see the back of the faces. But also, geometry would become low resolution, and it wouldn't have all of like the detail in it. And that was intended. Like, it is supposed to be low detail, but the problem was that it wasn't updating when I approached it. And that still isn't a thing. I just turned off the level of detail briefly while messing with infinite world gen to make sure that it can generate an infinite world. But now that I've multi-threaded mesh uploads, I have a lot more overhead to be able to like regenerate distant meshes to either be lower or higher resolution without halting the main thread. Because that's the biggest thing that was stopping me from having that automatic level of detail as I move, was that mesh uploads were taking up a shit ton of the main thread's time, and it was causing the entire system to kind of halt. But now that mesh uploads are entirely decoupled from rendering, I can just like do that. I can just have the meshes get uploaded constantly in the background without it slowing anything down. In my engine, there's a 2-chunk buffer that isn't rendered but is generated, so that means that chunks aren't generated and meshed at the same time. Do you do something similar? First off, I'll answer the second question, multi-threaded uploader meshing. Both the meshing and the upload are multi-threaded now. Okay, so in your engine, there's a 2-chunk buffer that isn't rendered. So I still have that, in the sense that like there is a 1-chunk buffer for me that is not meshed out in the distance. Or I guess it's more one like render block, because sometimes the really distant terrain can render as more than 1 chunk, and it has to have at least a buffer. I guess it is actually a 1-chunk buffer, actually, because it only needs to know the blocks directly against it. Why do you have a 2-chunk buffer? I'm trying to think why that would be important. Because, like, for me, I know I need the 1-chunk buffer to make sure that the chunks at the border properly mesh the sides of the other terrain. But, like, why do you need 2 chunks? Yes, it is multi-threaded uploading, and it is in Vulkan. That was, like, one of the main things that I swapped over to Vulkan for, actually, several months ago, but I only implemented it, like, today. So it's kind of been a long time coming, but I'm really satisfied that it's here now. I was using OpenGL for this project for several years, and there's still a couple stains on the engine because I swapped over. Like, I don't have proper ambient occlusion or anisotropic filtering back in yet because I cut out a lot of the advanced rendering stuff when I swapped over to Vulkan temporarily, and I haven't really like finished setting that up yet. But yeah, Vulkan's really cool. I like it a lot. My chunks are 16x, so 2 chunks would be equivalent to one of yours. Yeah, okay. Yeah, because mine are 32x. The 2-chunk buffer is so that the lighting updates can bleed into chunks on the edge of the world rather than be... That's really smart. Okay. Yeah, that's something that I've been thinking about for my system. Unfortunately, I can't do something like that, because, like, I want to be able to have skylight that cascades down infinitely, and I have infinite world height, so I'm still really not entirely sure how I'm going to do light cascades like that without things melting. I have a bit of an idea, though, that I think is kind of cool. I'll talk about it in a sec. Let me just read this. Wait a sec, so that's how chunks are generated / rendered and why you can fly into an empty chunk in Minecraft. That was kind of obvious, but until you explained it, it didn't click for me. Oh yeah, no problem. Yeah, basically, like, a given chunk needs to know what faces on the edge of it are going to be visible, and it can only do that if it knows what's occluded by other chunks, because of course none of the faces down here are rendered except for the ones that are at the border, right? But at a chunk border, then whether or not a face is occluded depends on what the next chunk over is doing. So you kind of need one extra chunk in memory that is not yet meshed yet to know what faces to occlude and what faces not to. There's actually something really interesting that someone at my game dev club brought up. Like, I do like a university game dev club, and they were working on some Voxel stuff. I think they said they didn't invent it, but either way, they brought it up to me the first time, and I thought it was really interesting, which was instead of having every mesh, or like every chunk solely responsible for all of its own edge faces, you make, at the borders, each chunk always be responsible for, like, the positive edges. So then you only actually need to check the occlusion of, like, 3 chunks. Or I guess it's 3 for the horizontal direction, and then 4 for the vertical direction, so 7, instead of, like, a whole 26 around it for checking occlusion. Because, basically, like, in any given chunk on the negative directions, it would actually mesh the previous faces from the other chunk itself, I think is... Or wait, no, sorry. For the negative directions, those faces will be rendered by the chunk to the left. That's not a good example. Let me get a visualization for you. Hold on. 2-chunk buffer so the lighting updates can be... Is the color palette being the same as the transflag a coincidence? Funny if not. Are you referring to the game, or my computer, or everything about me? Because, no, it's not a coincidence for any of those cases. I didn't know that multi-threaded GPU uploading was even a thing. Interesting. Yeah, it is in Vulkan, and technically in OpenGL, but you have to do some really cursed stuff with effectively creating 2 OpenGL instances and sharing memory between them, and that was never something that I wanted to commit to figuring out, because it looks awful. I thought we worked out a way to do Sunlight and Zephyr years back. Yeah, there's a tentative idea, but it's still kinda weird. There's like a lot of technical hurdles to it. The basic idea that, we came up with for handling sunlight that can cascade down potentially infinitely is to, A, assume that everything's illuminated by the sun and then delete things under dark patches. But that is standard for all Voxel games. But more specifically, so that shadow can't cascade down infinitely, I actually have it so that sunlight can cascade diagonally every, I think, 8 blocks or something. So if you have like a floating island 3,000 blocks in the air, instead of it just having a straight line of darkness that goes all the way down to the surface no matter how far it is, it actually kind of goes in a bit of a cone and eventually tapers off at the bottom. It prints the milliseconds when it goes above 16, that's a nice debug feature. Yeah, I used to have a graph that showed the frame rate, but my debug menu's kind of fucked right now, as you can probably see. So for the meantime, I just have been doing the frame warning stuff. It's not particularly liking how much terrain I've got meshed. It's actually going outside the far plane. There's way, way, way more terrain out there. In fact, let's see. Yeah, I'm currently using 9 megabytes of VRAM, or 9 gigs of VRAM for all this terrain, because I don't yet delete the old chunks. Let me kill that real quick, and let me get an example of the mesh gen stuff I was talking about. Let's open GIMP. So, basically, right now, if I want to mesh a single chunk, say I want to mesh a chunk that's like here, and we're gonna do this with a 2-dimensional slice because it's simpler. Say that this is my chunk that I want to mesh. I actually need to know all of the chunks around it to know what edge faces should be rendered. Because basically, I need to know this data here. Like the entire row of blocks on the outside of this chunk on all directions. Which means that I have to decompress/generate a lot of information to send it to the mesh generator on a different thread. Which is kind of annoying, because that means that there's a lot of extra work that has to happen on the main thread, because I don't want to multi-thread the dimension class itself, because that would take a lot more time to like do atomic stuff. So instead I just copy the data on the main thread. But there's actually a way that you can do this while only taking in this data, these chunks. Because what you can do is you can make it so that this chunk is not only responsible for meshing its own blocks, but also the side faces of these chunks. And then what that means is after that, this, like any given chunk that is being meshed, doesn't have to mesh any of these side faces of it, because they're handled by the chunk that's to the bottom left of it. Which means that effectively you don't need to have any of the occlusion details over here, because the chunk that's like either here or here or here has already meshed the right faces, these faces, from when it was its turn to mesh. Which basically means, so in this example it goes from 8 neighbors to 3, but that's in 2D space. In actual 3D space, this takes 26 neighbors, because it has to get the 9 above, below, and the 8 on the horizontal axes. And over here it only needs 7 neighbors, which is a lot less. A lot less. So I want to do that system eventually, where basically you mesh like the bordering faces of the previous chunks on the positive edges of the chunk. Why GIMP instead of tablet? I actually have... Okay, so if you're just talking about why I'm not using my regular tablet, it's because I don't really know where it is, because I still haven't fully unpacked from PAX. It's somewhere in my room. My room's a bit of a mess right now. But I also have this like really cool drawing tablet that I bought that's like sitting right next to me, which would be a lot smarter to use, but I don't have the cable for it right now. I need another HDMI to DisplayPort, and I don't have it, so I'm also just kind of sitting on that. So the result of that is GIMP. Let me quickly read chunks. Potentially stupid question, but what causes the faces in some directions not to be rendered? That is an optimization that attempts to not generate chunk data that would not, or mesh data that won't be visible, because I already need to remesh chunks as you move in the world anyways. I basically say if you're beyond a certain threshold from where the player is expected to be, which right now is 0, 0, 0, then it stops meshing faces that are away from the player. So you can see like it's not rendering these faces, and then when I get far enough away, it's not going to render these faces either. And the idea is that as I move, it should regenerate these meshes to add those faces, so you don't ever see it like this, but I haven't implemented that yet. And that's why some of them are not rendering. I reuse chunks from the world moves in my engine. I wrote a custom library from it. The chunks aren't moved in memory, just an offset is changed. Oh no, why is there a pop-up? The offset is changed and the chunks are wrapped around. I want to be caching as much chunk data as I can, so instead of doing that, I mostly just compress it using run index encoding, and eventually I'll discard that data if the memory gets too high, but it's basically going to try and keep chunk data around as close to forever as possible in memory, because I want to be able to continually generate lower resolution versions of the distant terrain as I go. I want the render distance to be very, very large in this game. I had the exact same problem trying to remake Minecraft LMAO. That's genius, actually. Yeah, I mean, don't credit me. I'm assuming you're talking about this thing. Don't credit me. Credit the person that told me, that also said that they didn't figure it out themselves. So, I don't know. There's like a multi-level stack of plagiarism here, and I can't actually fix it because I don't know who initially made it. But yeah, it's a really cool idea, and I really look forward to trying to implement it. Gabe says you should only need the neighbor chunks in a cross shape, so the 4 neighbors, not all 8, right? Normally, yes, but I have a bunch of weird stuff that happens right now, where I allow meshes to dynamically create, like, extra faces on them depending on what the neighbors are, which can go diagonally, so I do need the diagonal chunks. Like, for example, you can see, like, this grass that comes up here. This is actually a part of, let me grab some stone. That's actually a part of these grass blocks. Like, the grass blocks themselves mesh it. They don't go diagonally. I don't think there's any example of anyone going diagonally. But, like, the system should be able to support diagonal testing. Oh, actually, wait, no, this does technically go diagonally, because it goes from this block to this block, and this is a diagonal test, which could, if I only have the direct neighbors, not be readable, if it was, like, at a chunk border. So I do need the diagonals, at least for, like, the edge blocks, to be able to properly compute extra faces like this. But yeah, all of this stuff is done at mesh time. There's no state in the blocks themselves. It just queries the position of neighboring blocks and then enables or disables subsections of the mesh. And it's actually really efficient because it just uses a shit ton of bit masking, and I'm really happy with how it worked out. One day I want to do a video on that, but that's a little ways away probably. I have way too much stuff that's already not finished that I need to work on for video stuff. Before generating a chunk mesh, I copy the sides of the neighbors into a chunk extra struct. 18 by 18 by 18 with some helper methods that I do to not have to do additional math. 18 by 18 by 18 wouldn't be ideal because it's not a power of 2, it slows down lookup times. Yeah, 18 by 18, I do always want it to be a power of 2. I have a lot of space methods for converting things from like a local position to an index that work best with powers of 2. But like not copying the entire chunk and just copying the edge would be a really good idea. I did do that before and then I swapped out of it for some reason. I think I couldn't quickly generate those like extra values for it was for I think lower resolution chunks, but I have systems in mind to fix that, so hopefully I'll be able to like move that work over so that I'm not copying entire chunks, because yeah, I agree, it's pretty dumb. Bitmasking. Yes, I'm using bitmasking. Or wait, are you asking what bitmasking is? Please elaborate. Wouldn't it be 9 neighbors on the second version? I don't think so, because in 3D space, if we do this in 3D, you would need all the positive edge neighbors, which means you'd need 1, 2, 3, and then 4, 5, that's sure, 6, and 7. Yeah, so it's 7. I hope this graph helps. Oh, I'm sorry. Moving struggles, fair enough. New tablet, cool. Yeah, I'm really excited. It's the Huion Canvas GT221 Pro. It's like the size of a computer monitor. It's horrifyingly massive. It's exciting. I can't wait to use it. I wonder how Ken did the voxel meshing in slab spree. It might be a bit of a different algorithm since certain voxels are sparse structures. I don't know what slab spree is. That sounds cool. Let me know if there's anything interesting going on there. Trixon subscribed with Prime. Thank you for the subscription. Okay, I think I understand now. Great. Yay. Okay, so everything in computers is composed of binary, which we call bits. We can use bits as masks. So 110, 110 could be a mask that says where blocks are. All the ones represent blocks. I recommend having 6 meshes per chunk, 1 per facer, instead of 1 in the way that you don't need to read down the meshes unless you actually want to unload the meshes that face away. I guess that's simpler. Okay. A couple things there. So I'll explain bitmasking in a second. I don't want to have more than 1 mesh per chunk. mainly because I'm hitting a lot of draw call limitations right now, and I'm already doing a bunch of optimizations to have more distant terrain, like, occupy more than one physical chunk. It could be possible that I could do that more aggressively in the near chunks as well now, because I want to, because I have the multi-threaded mesh uploading. Like, because previously the problem was that mesh uploading took too long and it would make the frames stuttery, but now I don't have to worry about that. I might be able to easily make each of these meshes 64 by 64 by 64, which would be an 8 times reduction in the draw calls already, which means that multiplying the number by 6 based on the edges would actually be a net improvement. That is something that I could explore, and I might try looking at that, but I need to do some, like, testing to see how feasible it would be to do 64x meshes everywhere anyways. I think I was including the boxes that had negative z-values in my count. No worries, yeah, the 2D to 3D has a lot of stuff like that. What's the blue on the... Wait, what's the blue on the ground? Is it supposed to represent streams? If so, that's really interesting. It's actually just, like, a weird aesthetic thing that I was doing. I was originally trying to make rivers, and then I realized I didn't have, like, a good way to cut into the terrain with the topsoil yet, so I just did some funky alien, like, vein patterns. And I think it's kind of neat. I don't know if that's going to be, like, in the final version of the project, but I do like having, like, the weird different topsoils. It was basically just a test of the map generator. Ran across your latest video recently, really enjoyed it. Love your presentation style. Is there a video where you talk about the game more broadly, like your vision or intentions for it? Thank you, first of all. No, I don't have a video where I talk about the game yet, mainly because I don't have any game to show. I started trying to script one a couple months ago because I figured it would be a good idea to talk about my game relatively early on so that people aren't, like, A, surprised, or B, confused when I start making videos about making an actual game. Because, like, I don't plan on just doing tech videos forever. Like, I love doing tech videos, but I also want to talk about game design and talk about my project in more detail, like, as a work of art as opposed to just a work of tech. But I have basically no final assets at all, and so as I was scripting, I kept running into the fact that I can't show anything, and that kind of screwed me over. I might make, like, a slightly lower energy video that's more just me talking to the camera to talk about that. Like, I just feel like I don't want to do something that's not particularly engaging, but I also don't have any resources to demonstrate. Maybe I could do something like what Artificial does. Really good game dev YouTuber if you haven't heard of them. But they do, like, a lot of minimal visualizations even for gameplay stuff, and I could probably do that as well. But yeah, we'll see. Have you tried multi-draw indirects? Yes, I have. Actually, hold on. I think someone actually asked how many draw calls there were earlier, and I missed that, so apologies, but I can show that now. So I'm already using multi-draw indirect, but even then I still find I'm somewhat draw call limited, because, like, it is still independent draw calls. It makes it more efficient to upload, but, like, it still does all of the draw call work, just slightly less transfer work. So, like, yeah, let's just get, like, good full scene here, and screen cap, and kill. That should kill it, hopefully, unless I've got a deadlock. Nope, we're good. Yeah, so if I look at the first color pass, which is where it's actually generating all of the meshes, I do multi-draw indirect. Let me flip this. And then let's look at the albedo output. Yeah, so I do have, like, about 120 chunks that are in each indirect buffer at any given time. And I do that, the reason it's not more is because to do multi-draw indirect properly, you need all of the meshes to be in the same buffer, and I only want to allocate buffers that are so big. I don't want to create, like, a weird multi-gigabyte buffer and then not potentially allocate, or, like, use all of it. Make a marble grass biome. Huh. That's kind of what this is already, but, like, different, I guess. I've seen some voxel engines that use 62 by 62 by 62 chunks instead of 64 or 32, so they can use bitwise operations to do the face culling both within the chunk message limit. Huh. I guess, like... I guess that means that they can upload it as one structure, but it means that, like, for the actual chunks, I assume they're still storing it as 64 by 64 by 64 so that they can access it easily, but then all that extra data is just wasted, which feels bad to me. Or there's data duplication, which feels even worse, because desync data is not fun. I mean, like, it kind of makes sense. I don't really want to go down that route, though, because that makes me feel slightly queasy. Oh shit, hydrate. Ah! What program is that? I assume you're talking about this one here. This is RenderDoc. Oh yeah, I guess my toolbar isn't visible. This is RenderDoc. It allows you to basically take a snapshot of an individual frame of your game and then analyze it. Oh, thank you for the posture check. Oh yeah, just to answer the question a little bit more for KGHM, most of the time when I'm talking about my game's design, I'm mostly talking about it on stream. Like, this is definitely a bit more of a technical stream, as have most of the ones recently, because people keep coming and asking technical questions, which is awesome, but also I never do any code on stream anymore, oh my god. But yeah, no, I do occasionally talk about game design stuff, and I do hope to be able to do that more directly in a video soon. But yeah, I think I'm gonna get the voxel meshing videos out of the way first, and then I'm going to hopefully try and make a video about the actual game design of the game I'm making. So, yeah, I guess one thing which I could mention, like the chunk is 62 by 62 by 62, and all the blocks are stored like any normal chunk with whatever may be, but they also have a bitmap that represents all opaque blocks. But then that means that, like, the actual chunks themselves, like the data is not a power of 2, which would make accessing it so much slower. Yeah, sure, send me the Git repo if you want. I'll take a look, but that seems very confusing and counterintuitive to me. Right, what was I saying? There was something that I was gonna mention. Oh yeah, the meshing videos. So, the reason that I'm actually working on the engine right now instead of just grinding out video production is because there was one more thing that I wanted to go over for the videos that I hadn't yet, like, implemented, which was multi-threaded mesh uploads, and I learned from the textures video that I should never ever talk about anything I haven't already done in practice, because that leads to me accidentally getting a lot of things wrong, and I don't want to mislead people. So, yeah, I basically had everything else that I wanted to talk about implemented, and then I just wanted to cap that second video off with talking about multi-threaded mesh uploads, but because I hadn't done it at all yet, I didn't want to talk about it. But I wanted that video to have it, so I basically just rushed to get that working. And I'm honestly really glad I was motivated to do that, because it's really, really nice to have it working. Like, it just makes the game so much nicer to work with right now, like, already. But yeah, so I'm glad that I got that sorted, because it's very important to the project, and also nice for the video. Do I have a plan to eliminate more I don't know how to pronounce that. I know what it is, but more patterns in the distance? Yeah, I'm basically going to be doing voxel level of detail, where, like, in the distance the voxels are going to be larger and represent more than one block, and also be single color after a certain distance. And I plan to just kind of thread the needle where right when it's about to have a more artifact, then it's gonna go down another level of detail, so it's just big enough to not do that. Also, I will probably have an isotropic filtering, but that's mostly beneficial for the up-close. It doesn't affect the far-off terrain that much. Also, I love that I can just, like, zoom in as much as I want. I have, like, an uncapped zoom, to the point where if I zoom too far, then it will flip around because the FOV gets too low. But, like, it's very helpful for development to be able to, like, zoom all the way over there. In my voxel engine, I'm not worrying about performance too much. My main goal is to get the engine to a point where I can start working on the game I want to make. That's very fair, and probably what a sane person should do. There's two reasons that I'm doing this right now. The first is that I do want to release the engine as something other people can use, not just me. The second is that I like making systems, and there's actually 3 reasons. The third is that I am terrified of doing the actual game design. Like, I have a ton of ideas in my head, but ideas are just ideas, and until you start making them, you don't know if they're going to work properly, or if people are going to like them, or if they're, you know, if the things that you've been brainstorming for, like, the past 5 years are any good at all. And I'm really scared of getting to the point where I start working on the game design and then finding out that my ideas just don't functionally work together, or that everyone hates them, and then I have to figure out what the hell I'm gonna do. You know, that's like one of those really interesting things where, like, voxel games in the past have had this weird history of kind of the control being taken away from the artist, in the sense that, like, Infiniminer, like, Zachtronics quit working on Infiniminer because he didn't like that people didn't want to play the game that he was making and wanted to make their own game. Notch made Minecraft and tried to make it, like, general, but then started to get these ideas of doing, like, a Dwarf Fortress kind of thing, and people didn't want to do that, and he got pissed about it as well. And, like, you know, I mean, not trying to claim anything positive about Notch, we all know a lot of things about that man at this point, but, like, there's this really interesting thing where you create something that has so much flexibility, but that kind of removes your agency to actually create what you want in it without, like, the risk of people rejecting it. And, like, I don't want to get into a situation where I'm effectively fighting the people that are interested in my game to make them like the game that I want to make, because that's not possible. Like, if people don't want to play the game you want to make, they don't want to play it, right? And I also don't want to, I guess what I'm saying is, like, I will go with the flow if people don't like the idea I'm trying to make, but I'm really hoping that that's not gonna happen, and I'm mostly just avoiding starting to work on the game design at this point because I don't want to face that if it does come up yet. Because I'm scared. I'm scared. What is this message? Hold on. Hi, can I keep your company in your difficult task? I will carefully write obscenities in the chat and provoke you. If you are ready, then approve your new follower with a like. You know you can't like Twitch posts yet, right? Like, or like at all. Like, you can't? Okay, sure. Sure, yeah. Say horrible things. We'll see how that goes. If they don't like the game, just beat them up. Yeah, that's a good idea. It is time to remesh, or to implement remeshing when moving so that the missing faces are fixed. Yeah, definitely, definitely should do that. Because, like, I don't know if you've noticed, I tend to do this thing where I just run into the distance when I stream and talk about things. I mean, I'm sure you've noticed that, but I've been trying to explicitly avoid looking behind me because it looks stupid. But yeah, the first thing I need to do is implement mesh deletion again, because until I have deletion, I can't remesh things without just wasting infinite amounts of memory and then creating the end of the world. But after that, yeah, I need to make it so that the mesh level of detail follows the player. And then I also need to make it so that level of detail is used at all, because, like, right now, even the distant chunks that it's meshing are still full detail, because I just disabled that for the infinite mesh generation stuff. It's cool to see it, like, generating right at the next point with the zoom. It's funky. Ooh. It's on GitHub under the user Cgerishk. Hold on. GitHub.com/CGERIKJ/binary3D-mesh. Cool, okay. I'll take a look at that. I think someone actually linked it to me already. That might have been you. But I haven't looked at that yet. Good old doing something paralysis because I overthought stuff. Good luck with beating it. Yeah, it's one of those things where, like, the outcome of something becomes exponentially more important the more time you invest. Like, I was so scared of uploading my next video because what was supposed to be a 1-month project turned out to be an 8-month project. And then suddenly it was like, oh, I had all these expectations that somehow this one video had to do the equivalent performance of 8 videos over 1 month each. And of course... Oh, uh-oh. I might have killed it. Hold on. I probably maxed out the VRAM. Okay. Are we still live? Did it work? Okay. We're fine, we're fine. Okay. Yeah, what was I saying again? Yeah, like, of course the video didn't do that, and by the time that I uploaded it, I was content in the fact that it wasn't going to, because that's not a realistic goal, for sure. It did perform quite well, like, for one video. It's just, I had these unreasonable expectations for it to perform like many videos because it took the time that I expected many videos to take. However, a lot of that was external time that was, like, kind of just pushing in on me from all directions because of school and work and a bunch of other stuff, and I have a much more clear path in the near future to get more videos out, so I'm really hoping that I can get, like, the second and third video of that series out in a much more timely fashion. In fact, like, this whole thing that I just did was all to get the last topic that I needed to be finished myself for the second part to be done. And now that I've got the multi-threaded mesh uploading, I can make that full video. I just need to script it and edit it and write it and speak it and then edit it again. So that's gonna be great. Welcome, Occam's Chainsaw. Chainsaw. That wasn't a like a lisp. That's just what it is. Chainsaw. My god, that keyboard is loud. Yeah, it really is. Sorry about that. The mic is not very good for ignoring keyboard sounds, and I am a mechanical keyboard lover. Trixon says, what does the task status represent? It's basically a bar showing all of the worker threads, because I swapped over from having like a set amount of mapgen threads and a set amount of mesh threads to having a task executor that takes in tasks into a queue and then basically sorts them into a multi-threaded buffer by their weight. And so the blue tasks are mapgen tasks and the red tasks are meshgen tasks, and every square in that grid is one thread, basically reporting its status every frame. Which is actually, it's really interesting when you work on the level of microtasks like that, how that bar can be very deceiving, because despite the fact that it is, like, updating every single frame, there might be a dozen or 24 tasks that are running during one frame. And of course, since, like, per frame is the highest precision I can give, it just tells you the current task that is running right at, like, the moment that it's pulled, which isn't necessarily representative of what it's been doing for most of the time. I just kind of have to accept that that data is intrinsically a little bit flawed, and work with what I can get. But what it has done is show me that, like, the multi-threaded mesh uploading has done a ton for performance. Like, if you look, I'm flying at, like, max speed right now. I'm sprinting and flying, which is very fast if I, like, show you the blocks. Like, I'm traveling by probably, like, 10 or 12 blocks per second here. And it still, like, has time in between these mesh generations, which is really relieving, because in the old model, it was not fast enough to do this without having, like, a ton of, like, slow down and backing up all of the mesh gen and stuff. And there's a ton more optimizations that I can do now that I have the task executor. So, like, there's just, it's only gonna go up from here. It's only gonna get better from here, which is really exciting. I'm very enthusiastic about that. Looks like Ken is storing the voxels in a compressed format where he roll encodes the surface voxels along the z-axis. Looking through his code now to find where he meshes his voxels. Those are words that I don't understand. What is roll encoding? Who cares if the bar is deceiving? It looks cool as heck. Yay. No, I mean, like, it's deceiving in the sense that it doesn't always tell me the full picture, but it is useful. Like, it still provides useful information. Like, when it's gray, like, if there's stutters of gray, I know that, like, a thread has been idle for long enough that that's reportable, which is very bad. So, like, if there is, like, gray in the middle of it doing work, then that's very bad. Gray at the end is fine, because that just means that it's not got anything to do. But, like, if it's currently in the process of meshing and, like, little gray pixels are showing up, that means that I'm not queuing enough information to properly have all the threads being used at once. Oh, run length encoding. Okay, I'm assuming you're talking about run length encoding. Autocorrect sucks. Yeah, so, the task status bar, it should be less empty in the future. Oh my god. Sometimes people drive past my window without mufflers on, like their cars, because they're assholes. It's really annoying. Run length encoding, yeah. I do use run length encoding for, chunks that are far enough away, but it kind of decompresses them into full memory and then stores them there for a little while when they're used, because I want to always have like meshes, or like I always want it to be easy to access the data that is currently being used by stuff. I want like a direct array index as much as I can get. One thing that is bad about the task executor right now is that, oh wait, how many milliseconds does the task for generating one chunk mesh take? That's a great question. I can profile that, actually. Let's do a quick profile, because I don't really know. If we go to world, we have the average time bytes per mesh. So let's do a comp average F32 time per mesh, and then I'm going to go over to the world, and in the mesh processor task, if we go timer t right around here, and then go time per mesh dot add t dot elapsed seconds. That'll add it to the rolling average, and then if we just go over to the debug printing, let's go average mesh gen time, then let's just go time per mesh dot get times 1000 milliseconds. Okay, let's find out. It might actually be very skewed, because yeah, it's going to be very skewed. I might have to do another thing for this, because that includes meshes that have 0 vertices in them. So it's probably going to be very close to 0 this whole time. Let's find out. 3.05, 3.23, 3.25, 3.3. Okay. Huh. So it's still staying relatively high. Did I do this right? Where's the timer? Time per mesh.add. Let's go, if has non-empty, then we're gonna add the time here. This is actually scary, because that means that this average time could be much worse than I initially thought. Roll is RLE is run length encoding. Oh, okay, that makes sense. If I were rasterizing voxels, I definitely would be generating the mesh on the GPU. Like using a compute shader to generate the meshes? Huh. That's an interesting idea. I don't know how I would even start doing that. Yeah, I'll keep thinking about that though. Yeah, so average mesh gen time right now is 3.93 milliseconds per chunk. So that is something that can definitely be improved using a compute shader and atomics. Interesting. Huh. I'd have to get all of the, like, properties in there, and it would take a bunch of branching. That would be weird. I might look into that, but yeah. I've seen some post about generating the mesh with compute shaders, but right now it looks too complicated to be worth it. Yeah, like there's a lot of stuff I do at mesh time that requires a lot of branching and querying and bitmasking and stuff. Like, I don't know if it could be parallelized very efficiently, but I know that with conventional programming, there's a ton of optimization that I could still do here to make the actual per mesh time a lot faster. So many cars with no exhaust, yeah. I already do it in a separate branch of my Voxel engine, actually. Oh, interesting. I'd be interested in seeing that if you have it. I would imagine doing mesh gen and compute would run into bandwidth issues. Yeah, I don't know. Oh, hey there, Quantum Developer. I watched your videos on YouTube. I like your, like a lot of the stuff that you were doing with the colored lighting stuff and the vertex pulling. The vertex pulling video blew my mind. I love it so much. I'm so excited to try doing vertex pulling on my own like Voxel engine now, because I watched that and I was like, holy shit, that's so cool. You can probably improve that with binary meshing. Yeah, I agree. That is something that I do want to look into. I don't really know much about it, But it's something that I do want to explore. How fast is that generally? Oh, the GPU mesh generation. Okay, I can't answer that question because it's not directed at me. Where are we right now? Like, broadly in the context of the stream, what am I actually doing? I'm trying to think, like, should I write some code? Should I actually do some programming? Maybe. Something that I am kind of interested in doing that's like a relatively simple task, probably, is making the mesh tasks not just do one mesh at a time. Chatting, yay! Yeah, because, right now the map generator generates a lot of terrain at once. It generates, I think, 64 regular-sized meshes. And then at the end it tells each of them to be meshed independently, which is not super optimal because the mesh tasks, while they do often take up a lot of time, you can also often get chunks that have zero, like, solid blocks in them at all, which means that they shouldn't be meshed at all. So it might be very useful to group them together, so then I know that the thread is at least doing something for a bit of time, although that doesn't actually solve the problem, because if I'm combining all of the chunks to mesh together spatially, chances are the meshes that are in the air will still not have any actual chunks in them. And then that just adds a ton of variance to the amount of time a task can take, which is not really what I want. So maybe it doesn't make sense to group them. Maybe I should instead be trying to early exit out of generating meshes that I know don't have any terrain in them. I guess, like, that might work. Because, like, sorry, I'm, like, slightly tired today. I don't know. I got very little sleep during PAX. PAX kind of broke my brain. And so I'm still recovering. I accidentally slept for, like, 9 hours today, which is not normal for me. Like, usually I get about 6.5. I think my body's just like, please, please let me recover. But yeah, so if we wanted to screen out any chunks that are not going to have any terrain in them, then I would probably want to run through the chunks blocks and check if there's anything that is not air, because that's like a simple thing. Like, there could very easily still be empty chunks that have non-air meshes in them, because not all, that have non-air blocks in them, because not all blocks need to have a mesh, right? Like, it's possible someone adds, like, some special air that's around sometimes and still wouldn't have a mesh. But, like, it's really easy to check if a chunk only contains air, and so I think I'll probably do that, at the beginning at least. So let's see. That does introduce the issue, though, that I think the preprocessor should be able to not... or should be able to say, like, no, I do not want something to go onto the thread queue. Because right now the preprocessor, all it does is transmute the data, and then that data has to be sent into a queue. It would probably be better if I had an option to let it return an option. Like an opt mesh task val pointer. Of course, there's a bunch of horrible type stuff that would prevent me from doing that. Because, like, the task executor is, it's slightly awful. It's got a lot of meta-programming in it. I guess, like, what I could do, maybe, is, hey there, Patrick, how you doing? If I wanted to add the ability to have an optional preprocessor, then I should probably make a new type of task that allows me to set that. Yeah. Here from Graphics Programming. For a little bit before Elden Ring time. Oh, very cool, very cool. I absolutely love the graphics programming Discord. I basically shout it out every time I do a stream because people ask, oh, how did you learn Vulkan? And I'm like, by shamelessly asking questions in this Discord. That's awesome. But yeah, cool to have you here. I'm trying to think. So I saw something really, really interesting that the concurrent queue does, like the one that I'm using. That's a library. It has a second type parameter, which starts off with just like the Moody Camel concurrent queue default traits. And this is what you use to like override stuff in the thing here. And I wasn't entirely sure like how that works, because I was like, oh, well, how do I specify different traits? This is just like an object. And then I realized like, oh, you're supposed to basically create like struct my queue traits extends Moody Camel concurrent queue default traits, and then you can just override anything you want. Like, if I wanted to override the block size, also this should be a public extension if it actually is meant to work, I could go block size is equal to 64 in here. And then I just pass in my queue traits, and then it reads out of that, which I thought was really interesting. Like, it's cool to be able to parameterize a template type with more details than just like a linear, effectively like a tuple of type values. Because like right now in my task executor, I have this task type. Yeah, task type here, which takes in just like a bunch of parameters, and then it specifies a bunch of information about itself. But then it's kind of unclear, like, if I go over to where I'm actually using that, and I just see, like, oh, hash task type, then there's just, like, a bunch of things in here. Especially the voids really get to me, because it's like, what is this even saying? It's very hard to understand. And if I was to do something where I, like, went struct hash task, then I could actually go, like, struct props is extending some arbitrary type. Or actually, let's not do that just yet. Why would you need a separate type for an abortable task? Can't every task be abortable? Well, there's some cases where it doesn't really make sense to have that overhead. Like, if I'm returning, I guess I'm just, the only thing that it would be is just returning an optional pointer. Or even just like, it's returning a pointer anyways, I could just cancel out if it returns a null pointer. You might be right that it's overkill to do that. FYI, if you're declaring a struct, you don't need public on the inherited type since public's the default? Are you sure? Let's try this. I guess I don't actually have anywhere to... Hold on, let's go to, like, world.cpp here, real quick. And then I'm gonna have these... Yeah. Then let's quickly go down here. So much code. If I go const bx log x dot... Oh, you're right, it is public. Okay, that's cool. I didn't know that. I really don't like how struct and class have different, like, default semantics, even though I get that that's the entire purpose of struct, and I could just not use it, or not use class. Like, I engage with the evil, but I don't like the evil. Yeah, so why would you need a separate type for the abortable task? Can't every task be abortable? Yes, it probably can. Because the return type of the preprocessor is already a pointer. I could just return null. I really could, like... Let's see, I can return null pointer here. Why is it sad? What am I reading? So val is a const, what? It should be able to take a raw pointer. I guess, oh, it's just inferring it wrong? There we go, okay. Rustbrain does not like null pointer. Is adding opt that complicated? It's not complicated, it just adds an extra layer of overhead, which I don't really want. And yes, I know that that's kind of like a bit dumb and makes the code less maintainable. But like, I think it's better to do that. Oh, I already had a null pointer here? I guess I just wrote that. Hold on. I have a bunch of places where I'm already returning basically data in an invalid state because I was like scrapping this together last night and I wasn't really thinking very hard about what I was doing because I'm dumb. Let's... Oh, but... Problem. This is a unique pointer. Okay, or sorry, it's a raw pointer. Let's do some more horrible things. Let's create a make unique mesh task val and do this in it. Alright, and I'm gonna get rid of the valid property. That's only useful for the fact that I was returning data that I didn't want to mesh. So anyways, now we've got a unique pointer, which means that if I early return at any point, it will be cleaned up. But then what I want to do is return val dot release? Why can't I release it? Is it because it's const? Yes, val dot release releases ownership of the pointer and returns it, right? Yes, okay. So that'll do it. It's kind of gross, but whatever. Then we take in a mesh task val here. We don't care if it's valid or not because it shouldn't ever get here if it's null. And then finally in the task executor, after preprocessing, I want to go if val do all of this. Is there any reason your lambda couldn't return a unique pointer? No, there's no reason at all. It's just I don't want to refactor this quite yet. But it should. It definitely should. When I was writing this, it was like 2 AM, and for some reason I had it in my head that unique pointers would be slower, even though I know they have no runtime cost. And so I wrote the whole thing with raw pointers, and it's horrible. But yeah, that's something that I do need to fix up, for sure. So really quick, item is going to be Q element on val. If try and Q, do that. Otherwise... Okay. So... Okay. Cool, so I want to go... If val do this. Otherwise, it can basically just not. Pretty sure. This unique hack to auto-clean data makes me so glad I use Rust. F for C++ devs. This is, like, bad code. Like, it's not good. I think there's a lot better code you could be writing here that is not this. Please don't take this as the benchmark for all C++ code. But yeah, C++ is intrinsically kind of jank in a way that Rust isn't. Alright, let's see if I just added a bunch of seg faults, or if it actually works. Please? Please work? Uh-oh. Shit. What did I do? Okay, so we're returning a bunch of null pointers. Val is a unique pointer. Let's see, where is val being used? Val.level, val.chunks, return null pointer, val, return null pointer. Okay, there's a lot of null pointers. Then eventually we release it, which... Let me just look up the CPP reference unique pointer release. Releases ownership of the managed object. Caller is responsible for cleaning up the object. Yeah. So, this is definitely valid. And then this part down here should be fine as well. So it has to be something to do with the task executor. Which the only thing I changed was this block here. Oh, wait, hold on. I think I might be getting this. Yeah, because if val is nothing, then I need to delete the item still. No, I don't. I don't need to delete the item. But I do need to return and queue return code. And I'm just gonna go preprocessor null. Where is my queue return code? Preprocessor null. And then I probably need to branch somewhere on that. Let's see, where do I use in queue return code mostly? Here, okay. Let's just do a preprocessor null here as well. Yeah, because that's fine, because there was data, it just wasn't able to queue it because it returned null. I like to label my bad code as tracer code. It's there to attempt to solve a tricky problem. Oh, that's interesting, yeah. I'm not sure that's like where I would intuitively, or what I would intuitively label that in my head. Is there any reason your lambda... Oh wait, no, I already read that. Bye-bye, good luck with the optimization of air chunks. Thank you. Tracer does sound fancy. Elden Ring time, good luck with the tasks. Thank you. Alright. We have another psych fault. No! What have I done? Or wait. Wait, hold on. It's not a psych fault, it's an infinite loop. And I assume that's because... over here... do I not actually pop things? No, I don't pop the task. Okay. So I do still want to pop the task here. This branching code is getting really bad. I need to have like I need to like abstract this into different functions. Because yeah, this is like really icky. And then I do need to call delete task val, then pop the task, then return null. Okay. Let me just kill Zephyr. Because it was in a loop. Okay. Hopefully this should clear up the memory bullshit and also work. We're gonna find out. This should actually be a sizable optimization already, if this works. Please work. Okay. Let's see, if I fly around... Oh yeah, that's definitely like less time spent meshing for sure. And the reason that this is already faster is because we just pre-screened out all of the meshes that weren't able to generate. Because right now, when the world generates, it tries to mesh every chunk that was just generated there, and if it's at the border, which it always is going to be at the border, because, you know, we're only generating chunks at the edge of the world, then a whole, like, slice of them is not going to be meshable, because it's lacking the surrounding chunks. And previously, I was just sending that data over anyways, and then screening it out in the thread, but now it doesn't even go to the thread in the first place, which makes it a fair bit more efficient. So that's good. Now let's try and screen out the ones that only contain air, which is just one more step in the preprocessor, which we're actually going to do before any of the expensive work. So I'm going to go, has non-air. It's going to be false, and we're going to go, pre.pos. Where do I actually get the chunk? It looks like I always get the chunk here. So... Yeah, I'm gonna need to clean this up just a little bit, because I grabbed the current chunk everywhere. Yeah, this code, this part needs to be fixed. So, first of all, we're gonna go, we're gonna split this off into 2 loops. The first one is just going to resize the terrain, or I mean the list, based on what level you're having. I sent a video showing me GPU remeshing every chunk, every frame in the off-topic channel on your Discord to show the perf. Okay, yeah, alright, I'll take a look at that. That sounds great. So we're gonna do that. Cool. And then what I'm going to do is get the first chunk. What does raw chunk return? An optional of a raw chunk. That's... What does this do again? A raw chunk is either a shared pointer of a chunk or a string. Okay, perfect. So what I'm gonna do is I'm going to go let... Oh wait, hold on. I'm overthinking / underthinking this at the same time. Right now we only want to perform this optimization on near chunks. So first off, I'm going to get the current chunk. So let's go let chunk is equal to dim.getChunk pos, tree.pos. Then we're going to strip this out of chunk order. And then this should only be happening for the other chunks and should emplace them back. Which we can actually just do with an emplace back. Should be fine, then I don't have to worry about off by 1 errors. Okay, but additionally what we have to do now is we have to go val chunks dot emplace back chunk, just to get the first raw chunk in there. Good. And now what we need to do is go if, so now we need to do our loop. So let has non-air is equal to false for let I equals 0, I is less than chunk dot nodes dot length, or dot size, I plus plus, and we're gonna go if chunk nodes I is not equal to, I think I have a constant for air somewhere. Come on, case sensitive. Yeah, definition atlas air. It's not equal to definition atlas air. Is that not imported, or? What is that? That's not a word. Oh, this is all commented. Okay, do I not have an air value anymore? I don't. Wait, no, that's in TypeScript. Damn it. Okay, that's weird and dumb. Ooh, okay. I'm gonna leave myself a to-do. Create air constant. And I'm quickly gonna go look at nodes.ts, which is in the game script, and it generates 1, 2, 3 things. So we wanna go, if it's less than or equal to 2, so it's one of the internal blocks, then return null pointer. Oh, sorry, wait. If it's greater than 2, let's go has non-air is equal to true and break, and then if not has non-air, return null pointer. Okay, that should pre-screen out all chunks that are not, that don't have any non-air tiles in them. Oh, hydrate, thank you. Uh-oh. That was a seg fault. Recommend adding the to-do tree plugin to VS Code. Oh, okay. And let's take a look at, Let's take a look at my to-dos. Is this the to-do tree? Not this one? Okay. Wait, what? But is the search that bad? Oh my god, what? Space. Okay. To-do tree. Show tree view. No? Oh wait, it's right here. Zephyr! Oh, here we go. Can I make it flat? Yes. Oh, wow. That's painful. There! Whoa! Why is it scanning stuff from library? Can I disable... let's go to extensions. Or settings. Extensions. To-do tree. Excluded workspaces, excluded globs. Lib. There we go. Okay. There's all of my stuff. I like this. This is good. I love to-do. This should not be here. Oh, wow. My to-dos are awful. I have a lot. Magic number bad. Some of them are even just in, like, commented code. This is awful. No. I feel like I've just, like, suddenly been called out. Yep. I've been super called out here. Okay, to-do. Wait, is there one that says to-do like that? What keyboard and switches do you use? I'm currently using... So I don't know what these ones are, actually, that I'm using, but my all-time favorites are Boba U4Ts. Called out by past me, I know, there's so many to-dos in this engine. It's brutal. It'd be cool if it could sort by, like, most recently edited file. I mean, maybe that is what it's doing. Because it kind of looks like these are the most recent ones. Anyways, where was I? Oh yeah, we got a seg fault for some reason. What the hell? I bet it's because I fucked with this bit here. If I just always return null pointer here, just like for testing, no chunks should mesh, but it probably won't give me a seg fault either. Let's see. Yep, okay. Just as I expected. Okay, so it's something to do with this. We have 7 chunks in here, then I am placed back the first chunk. Oh, this is an array of 7. Oh, so it was default assigning at the end, which was causing it to... yeah. Yep, that makes sense. Okay, let's do that again. I love C++. I love that if I say that the array is longer than I actually put items in for, it doesn't warn me at all. It's great. Okay. Oh, still seg fault. Okay, wait, really? What happens if I just don't do that, and then I still have this extra redundant upload? Because this is not a very big part of the code base. Like, is it really that it... Wait, for I is less than valid chunks that size... Okay, still seg fault? Hold on. What is actually different here? This is how it used to be. We're getting some non-Euclidean errors here. This is great. Alright. Let's see. So... okay, no seg fault, as expected. So, why is... C++ skill issues. C++ is mean, okay? Look, just because it's a bully doesn't mean that we should agree with it. Okay, so we get the chunk here. Then I do all this logic. Let's just comment that out for now. And then I place back the chunk. And then here, the only thing that changes... actually, hold on. Let's do this even simpler. The only thing I'm going to change here is just val.chunks.emplaceBack. If I do an emplaceBack, does it freak out? It certainly shouldn't, but we're going to figure it out. C++ does sound daunting, but what's the alternative if you're looking for the best performance? So, I hesitate to say it, but I don't know if there is a better option. Like, because Rust is obviously a much more robust language and does things nicely and good and doesn't suck. But also, its memory model, while being incredibly robust, isn't particularly good for game development, because a lot of the time the cursed things that you do for game dev are unsafe intrinsically, and like you have to be very careful and do them properly, right? But like, Rust makes it very hard to do those things. Okay, so I'm placed back the chunks. There's 6 chunks in the chunk order. Let's comment this out. Get raw chunk at pre.pos plus chunk order I. Not raw chunk, return null pointer. We can actually just go like, let offset is equal, or let offset of chunk order. And then we can just go plus offset. There we go. This should be fine. This should still work fine. The logic's identical. It's just the only thing that's changing is we're taking a chunk here and then placing it back uncompressed. Oh! Oh, wait, hold on. I think I know why this is broken. Let's wait and see. Yep, okay. I can't actually... wait, can I actually? I'm having a real hell of a time right now. What is going on? This is like so close to being identical to what it already was. Is it really upset about me and placing back a chunk I got elsewhere? Like, that shouldn't be a significant impact. I think it is stupid? Wait, hold on. What is happening? So, this code works fine. To be clear, this code is continually A-okay. Let's see. So... yeah, so this code's fine. If I swap this over to use a range-based loop, is it still fine? Rust is good enough for game dev if you're willing to study different paradigms. Instead of object-based approach, you might go with ECS, which decouples data and logic, and as a result fits nicely into Rust's memory model. I really like ECS, and also, like, I know Bevy is built in Rust, and Bevy is, like, incredible from what I've seen. Okay, what the fuck? Oh my god, it's because I resize instead of reserve. Ugh. Why am I dumb? Okay. Fine. Okay, let's do this properly now. So we reserve, we do that, we get the chunk, and place this chunk back above all of this. Do that. Okay. Yeah, Bevy is fantastic. I really, really recommend Bevy. I do think that it is less performant on a low level, like if you're not doing something that aligns good with its system. Like, I don't think I could make this game as performantly in Bevy. What the fuck just happened now? Wait, so I reserve, then I am placed back. What? Does this return an optional? It does. Okay. Does this return an optional? No. Oh, but this could return null pointer. Okay. I think that's probably why. I hate null pointer. I hate null pointer so much. If there was a standard type that let me pass references, like, as contained values, I would do that all the time. I guess I could just make one, but, you know. I guess I could. Maybe I should. Maybe I should do that. Like a non-nullable reference type, and then I'd make, like, some sort of overloaded optional where you can have it, but you have to check if it's optional or not. I've been doing a lot of functional programming at work, and it's kind of been making me a bit of a dork, for, like, type safety and optional things. I really like it, but, like, yeah. Hold on, I need to swap earbuds really quick, because my current ones died. Alright, is the music still coming through? Looks like it. Good. Oh, hey, it worked. Okay, hold on, what? Kind of. Wait, what? Why am I getting so much stuttering? What?